All right, Algebra 2, Lesson 6. This is our last lesson before our review and test. And this is all going to be about scatter plots. So I'm sure you're wondering what a scatter plot is. A scatter plot is a graph of a set of data points, x and y. And then if y increases while x increases, we call it kind of a positive correlation. So again, as x increases, y increases. And vice versa, when we look at a negative correlation, we can say that, okay, as x increases, y tends to decrease. And then if you kind of combine those two, or you're not really exactly sure, if you're not really exactly sure what's going on, we would say that that would kind of have no correlation. Again, it's just kind of all over the place. We can't really tell. There's no obvious pattern. So let's look at an example. So if I look at, again, the cellular phone subscribers and cellular service regions, again, I could say that, and I don't have to necessarily have an exact number, but in my first graph right here, number 1, and then we'll call this one number 2, okay? So in my first graph, I would say that it has a positive correlation because as the subscribers increase, and again, that's in millions, the cellular service regions increase as well. And again, that's kind of vice versa, or the opposite as we look at number 2. This is a negative correlation because as subscribers, which is my x, it's on my x-axis, my x values, as subscribers increase, again, they're going from 40 million to 80 million to 100 million, my corded phone sales are decreasing. And that's my y. So again, the difference or the example is we can kind of tell that in our first graph, my values are moving up and to the right, whereas in my graph when it's a negative correlation, my values are moving down and to the right. So one kind of idea that we talk about is the correlation coefficient. And we often use the correlation coefficient. We use R for that. So correlation coefficient, and that's often denoted by R, is a number between -1 and 1. So -1 and 1. And it's kind of tells you how well a line fits into that data set. So if R is really close to 1, if R gets really close to 1, that means that it is almost a perfect positive slope. It's a linear positive slope. So again, close to a positive slope. And again, they're very similar, slightly like opposites, where if it's really, really close to -1, our R value tells us that it's close to a negative slope. And then again, if you think about what would happen if R equals 0, that would be like our example up here where we really don't have much correlation. We're not really sure if that's positive, if that's negative, we're not really sure. So an R equals 0 is kind of like no correlation. So let's kind of look at these examples. For each scatter plot, tell whether the data have a positive correlation, a negative correlation, or approximately no correlation, and tell whether you think it'd be closest to -1, -0.5, 0, 0.5, or 1. Well, in the first case, I think it's going to the positive side. It's moving up, but it's not necessarily like extremely accurate. It's not like a tight group of data points. They are a little spread out. So I'm going to say, because it's positive, I'm going to say it's either going to be 0.5 or 1, but because it's not super tight and close, I'm going to say that my R is approximately 0.5. Whereas if I look at number 2, I can see that my data set is very tight next to each other. They're moving down and to the right. So I would say that this would be, my R value would be approximately -1. And then on the far right here, number 3, again, I really can't tell what's going on. Some are moving up, some are moving down. So I would say that my R value is approximately 0, because I'm not quite sure. I don't really have a correlation there. Okay, and this is going to be our last example here. And again, this is kind of going on this line of best fit. And so again, the line of best fit, or the best fitting line, is how close can we get our data to fit an equation. So how close can we come up with an equation that's going to match our data? So we want this line to lie as close as possible to our data. All right, so if I look at this example, I've got this table, and it shows the number of alternative fueled vehicles in the United States, X years after 1997, approximate the line of best fit. So again, first thing I'm going to do is I'm going to kind of sketch out my data. And I'm going to say that I've got 2, 4, 6, and 8. Okay, I'm going to skip some numbers. I'm going to go 250, 300, 350, 400, 450, 500, and then 550 at the top. And so when X is 0, I'm going to get a different color. When X is 0, I'm going to say that Y is 280. And again, I'm going off of these numbers right here. So I'm going to put that right here. When X is 1, Y is about 295, so real close. When X is 2, Y is 322. When X is 3, Y is 395. When X is 4, Y is 425. When X is 5, Y is 475. When X is 6, Y is 511. So just over. And when X is 7, Y is 548. So real close to 550. So if I were to just sketch a line out, again, I would say, hey, my line's going to be something like this. So again, that looks somewhat of a linear line to me. It looks rather positive in nature. So what I'm going to do is I'm going to choose 2 points that appear to lie on the line. So again, I'm going to choose my first point, which we said was 1 and 1 and 300, which again, I know it wasn't exactly 300, it was 295, but I'm going to choose that again to come up with my line of best fit. Your line of best fit may not fit any of your data, but it's going to be very close to all of your points of data. And then I'm also going to choose this one, which was 7 and 548, but we can approximate that to 7 and 550. And again, we've practiced calculating slope, x1, y1, x2, y2. So slope, I'm going to take my y's and I'm going to subtract them. I'm going to take my x's and I'm going to subtract them. I'm going to get I'm going to get, let's see here, 300 minus 250, or minus 550 is negative 250. 1 minus 7 is negative 6. And so when I divide those, I'm going to get a slope of approximately, again, a negative divided by a negative is a positive, 41.666667, which is approximately 41 2/3. So now I'm going to go back and I'm going to use my point slope form, and I'm going to use my original value, this one right here, 1 and 130. So again, point slope is y minus y1 equals mx minus x1. So I'm going to take y minus 300 equals my slope, which, again, if we just wanted to approximate it, we're going to say it's 41.6. And then I'm going to have x minus 1. When I distribute this across, I'm going to get 41.6x minus 41.6. Still have y minus 300. I'm going to add 300, and so y equals 41.6x plus, let's see what that equals, 258.4. So that would be my approximate line of best fit. Again, let's say we wanted to use Desmos and type it in. 41.6x plus, forgot what it was, 258.4. And if I were to graph it and scoot out a little bit, again, the reason this one looks a little steeper is because of our x intervals. If we tightened up our x intervals, oops, whoa, way off. Okay, again, when I did my graph, I used x intervals of 2, 4, 6, 8, whereas that one was counting by tens, so that's why it looked much, much steeper.